We also have that dividing something larger amongst a group will give larger pieces than dividing that same something actually, not dividing the same something, dividing something smaller by the same group. Let's do one more comparison. We have f minus 6 over 56 hundredths, and we want to compare that to f plus 7 over 23 hundredths. Now this is a little different because we have our numerators are not the same and our denominators are not the same. So we can kind of do some baby steps to figure this out. First I want to look at, well, if I compare f minus 6 with f, I know that f minus 6 is smaller than f. So if I'm going to divide both of these by the 56 hundredths, I know that this f minus 6 over 56 hundredths will be smaller than f over 56 hundredths. But then I can try and compare this with f over 23 hundredths. So I'm trying to keep the numerator or keep the denominators the same so I can see a little bit clearer picture of what's going on. So since these are the same here, look at the size of what I'm dividing by. I'm dividing by 56 hundredths here and 23 hundredths here. Since this is larger, it actually makes this fraction become smaller because I'm dividing by more things. So then I have this comparison that f minus 6 is less than f minus 6 over 56 hundredths is less than f over 23 hundredths. So then I do my last comparison, f plus 7 over 23 hundredths. Now here we have f and f plus 7 are different while our denominators are matching. So I'm going to look and say, okay, well, f plus 7 is larger than just f. I'm dividing by the same amount, so of course I'm going to have more things here if I'm dividing by the same quantities in the bottom. So then I have this big string, and that shows overall I have this inequality f minus 6 over 56 hundredths must be less than f plus 7 over 23 hundredths. Now lastly, we want to look at some common phrases that we hear in English and see how we can translate these phrases. So a few common phrases we have are at least 3, no less than 3, 3 or more, at most 3, 3 or fewer, no more than 3. And I chose 3 just so we could have something to talk about, so we could understand what numbers we're talking about or what we mean. So we say at least 3. That means that the least we can be is 3. So that means we're either 3 or we're larger. So we can represent all the numbers that satisfy this. Let's say that C is equal to the number of people who order coffee or who drink coffee. So if I say at least 3 people drink coffee, you're telling me then that the number of people who drink coffee is 3 or larger. So we can write greater than or equal to 3. When we say no less than 3, that means we can't get any smaller than 3. So again, we have this same equality because the smallest that we could be is 3. So we get the same inequality again. Here we have 3 or more. So 3 or more, you're going to have 3, or you could have 4, or you could have 5, and so on, which again gets us the same inequality. Now when we say at most 3, then that means that the most is 3. So the most you can have is 3 people who drink coffee. That means that there's either 3 that drink coffee, or 2, or 1, or perhaps none. So one way that we could represent that is to say that C, the number of people who drink coffee, is less than or equal to 3. Which this expression 3 or fewer, again, 3 or fewer, we're going to be smaller than or equal to 3, which gets us the same inequality again. Lastly, we have no more than 3. So again, we cannot go over 3. So we're talking about these same numbers, 3, 2, 1, 0, which gets us this inequality. Now for our try this question, I want you to use equal to, less than, or greater than to show the relationship between, we have b over 4 and b over 7.